In this video, we're going to look at how you can turn a hexadecimal value into a binary value. So what we've got here is two example hexadecimal numbers. We've got 5, 6 and CF. So the first thing to do is remember that a hexadecimal is split into nibbles. So each of these individual values, so 5 or 6 or C or F, are basically 4 bits. They're a nibble. So what you want to do is almost separate those so it's clear that they're separate entities, they are separate numbers. Now, as these are nibbles, we know that half a byte or a nibble is in a binary table 1, 2, 4, and 8. Obviously, if it was a full byte, it would carry on 16, 32, 64, and so on. As we're dealing with a nibble, we only need to go up to 8. So all we need to do is work out, well, how do we make 5 out of these values? So we need to basically say, well, we need to turn this into 5 by using some zeros and ones. So we can say, is 5 bigger than 8? No, it isn't. So we can put down a 0. Is 5 bigger than 4? Yes, it is. So we put down a 1. And then we subtract 4 from 5, which obviously gives us 1. Is 1 bigger than 2? No, it's not. So we put down a 0. And then obviously 1 is the same as 1. So that becomes a 1. And when I subtract it, it leaves us with 0. So the first half of this hexadecimal number in binary is 0, 1, 0, 1. Now let's move on to the second value, which is 6. So using the same method as before, 6 is not bigger than 8, so we put down a 0. 6 is bigger than 4, so we put down a 1. 4 take 6 take 4 leaves us with 2. And then is 2 bigger or the same as 2? Well, it's the same, so that becomes 1. And obviously, we've got nothing left, so that becomes a 0. So the second half of this is 0, 1, 1, 0, like so. A good way to cross-check it is just add up the ones at the end. So 4 and 2 gives me 6, so I know that's been added correctly. So that there is the binary equivalent, and if you remember, it's simply just 2 nibbles. So that represents 5, and that represents 6. Let's look at the other example then, because this one uses slightly bigger numbers. So C to start with. Now, if you remember with hexadecimal, once we go above 9 and we get to 10, we turn to characters. So A becomes 10, B becomes 11, C becomes 12, and so on, all the way up to F, which is 15. So I know that C is 12, so I need to turn these numbers into 12. So I can do that in my head, really. You don't need to do the other method before. So 8 plus 4 gives me 12. So obviously 2 and 1 are zeros. So C is 1, 1, 0, 0. And then to work out F, this is a nice easy one actually, because F is the largest value you can have in hexadecimal, which means 8 plus 4 plus 2 plus 1 must be true, because 8 plus 4 plus 2, 1 equals 15. So all of those are 1s, which means the second value is 1, 1, 1, 1. And again, if you added these up again, if I added 8 plus 4 plus 2 plus 1, I would get F, or 15. And if I added up 1 and 1, which is 8 and 4, I would get 12, which is C. And there we go. That's how you turn hexadecimal values into binary.